Alright, this video gives a brief overview of the ideas in Chapter 9, which is on transformations, and specifically 9-1, which is on translations. By the end of this video, you should be able to describe and identify what a transformation is, describe and identify an isometry, describe and identify a translation, and also use a translation rule to translate a figure in the coordinate plane. Let's get started. Chapter 9 is on transformations. Now, a transformation of a geometric figure is changing it in the position, shape, or size of the figure. Now, specifically in Chapter 9, we will study 4 types of transformations and also combinations of those 4. 3 of those are reflections, where you're reflecting it across over some line. A translation where you slide it. It doesn't change orientation, it just slides. And also rotation, where you rotate it around some point. Now, it's important to point out that in each transformation, we have a pre-image and an image. So the pre-image is what's before the transformation happens, and the image is what's after the transformation. Okay, an isometry is an idea that's really connected to this idea of transformations. And an isometry is where the pre-image and the image, which happens after the transformation, those two figures are congruent. Okay, so in this translation where we have a picture of Spider-Man and it's translated down, are these two pictures congruent? Are they the same size and shape? The answer would be yes. Okay, and so translations are an isometry, creates an isometry, or they're isometric. Okay, a reflection. Now it does look a little different because it's reflected and it's not exactly the same, but we would still say that they're congruent. They're the same size and the same shape. So reflections are also isometries. Rotation, where you rotate it around some point, I would say yes, they're still congruent, the same size, same shape. Okay, a dilation where it gets larger or smaller, I would say it's not congruent because it's a different size. So it's not an isometry, but if you connect it with 2 chapters ago about similarity, a dilation does create similar figures. Okay, some practice questions. Tell whether the transformation appears to be an isometry. Explain. Number 7, I would say the 2 rectangles look congruent, so I would say yes. Number 8, it looks like a reflection here, but reflections are isometries, and they are congruent, so I would say yes. Number 9, the 2 circles do not appear to be the same size. It's probably a dilation. The answer here is no. Okay, specifically about translations. A translation is a transformation that maps all the points of a figure the same distance in the same direction. That's how the textbook puts it. The most basic way to understand it is you take a figure and you just slide it in any direction, and it creates a translation. Okay, I'm not rotating it at all. It's the exact same orientation. I'm just sliding it in one direction. Okay, now notice that ABC, the black figure, is the pre-image, and after we translate it, we get the blue figure, A prime, B prime, and C prime. Okay, once we make a transformation, we usually use the same letters, but you add a little apostrophe, or we call it prime, to know that it's different, but that they're connected or related in some way. Okay, in the coordinate plane, we can also do a translation. So in this square, we've mapped it so it goes to the right 4 units and then down 2 units. Okay, so down here, which is very important, the translation rule, we're mapping x, comma, y, the coordinate point, each point x, y will become, the x coordinate will be added 4, and the y-coordinate will be subtracted 2. Okay, just so you understand what that means, the point A right now is at -3, +3. Okay, now if I take this rule where, now this is the x, if I add 4 to my x, -3 plus 4 is +1. Okay, so I get +1. Let me go like this. This maps A maps to A prime, +1. Now 3 is the y-coordinate. Now I take y and I subtract 2. Now 3 minus 2 would also be 1. Okay, so A prime becomes the point 1, 1, which is right here, which is what the picture shows. Okay, let's try another point just to make sure we get that. If I take point B, now right now B is the point -1, +3. The point B. And if I take the x-coordinate, -1, and I add 4, I get 3. And if I take the y-coordinate 3 and subtract 2, I get +1. Okay, so B prime happens to be at the point 3, 1. Okay, we're taking each point in the figure and we're adding 4 to the x-coordinates and subtracting 2 to the y-coordinates. Just going to put this down here. Okay. Now let's take this triangle and let's use the transformation rule. X, y maps to x minus 2, y minus 5. Okay, I'll start with point R, and R prime will be -2 in the x direction. So in the x direction, I'll move this way, -2. Okay, and then in the y direction, I will go down 5. 1, 2, 3, 4, 5. Okay, so R prime will be right here. Okay, now if you prefer to do it using numbers, that's fine as well. The point R is -3, +3. I'm sorry. R is -1, +3. Okay, now if we take the x-coordinate, -1, and subtract 2, we get -3. And if you take the y-coordinate 3 and subtract 5, you get -2. Okay, now R prime happens to be what we graphed over here as R prime. Okay, let's do it again. Q, if I take Q and go -2 in the x direction, I go here. And I go down 5 in the y direction. 1, 2, 3, 4, 5. I'm right here at Q prime. Again, I'll do it with numbers as well in case you prefer that. Q right now is 3, 3. Maps onto Q prime, which is, let's see here, x minus 2 is 1, and the y-coordinate 3 minus 5 is -2. Okay, let me just make these. Okay, now finally for P, if I take P and I go -2 in the x direction and -5 in the y direction, then I get P prime. Okay, now P is 2, 1. That maps to P prime, which is x minus 2, sorry, 2 minus 2 is 0, and 1 minus 5 is -4. Okay, now I connect R prime, Q prime, and P prime and get the same triangle that's been translated to the left units and down 5 units. Okay. A few more examples. Now here we are moving it in the x direction +1 and in the y direction -4. Okay, I'll take point A and I will go in the x direction 1 and in the y direction -4. 1, 2, 3, 4. Here is A prime. Okay, now A right now is -2, 2. A prime, if I take the x coordinate and add 1, -2 plus 1 is -1. And the y coordinate 2 minus 4 is -2. Okay, let's take B. And again, I will go in the x direction +1 and in the y direction -4. And I get B prime. If you do it using coordinates, now either way is fine. Right now it's 1, 1. B prime, if I take the x coordinate 1 and add 1, I get 2. If I take the y coordinate 1 and subtract 4, I get -3. Okay? Now C, if I go in the x direction +1 and in the y direction 1, 2, 3, 4, -4, I get C prime. Now C right now is at 0, -1, and C prime, if I take 0, the x coordinate, and add 1, I get 1. And I take the y coordinate, -1, and subtract 4, I get -5. Okay? So if I connect these points, I have the image, the same triangle, just translated down. Translated to the right 1 unit and down 4 units. Okay, what is the rule that would have made this transition from the black figure to the blue figure? Well, if I pick any point, I'll pick point P. How far in the x direction did I go? I went to the right, 1, 2, 3, 4, 5, 6, 7, 8. I moved to the right, 8. So x, y would be mapping onto x, let's see here, in the right would be in the positive x direction, and I went 8 units. Okay? Then in the y direction, I've gone down 2. Now down in y is negative, so it goes to y -2. And here's the translation rule. Okay, number 1, if triangle JPT maps to J prime, P prime, and T prime, what is the image of P? Now if I took P, this is the pre-image, and mapped onto, it'd be P prime is the image of P. Okay, what's the image of TJ? Well, T would map onto T prime, and J would map onto J prime, and so it'd be T prime, J prime. Okay, I'm going to skip 2 since I've already done 2 examples like that. It's just now there's 4 points instead of 3. Number 3, if point H moves 12 units to the left and up 4 units, what is the rule that describes that translation? Be x, y, maps onto, now see here, in the left would be in the negative x direction. So it must be x -12, and up is a positive y direction, so it'd be y +4. Okay, again in recap, this video gave a brief overview of Chapter 9 on transformations, which again is where you change the shape, size, or position of a geometric figure. Okay, and also on translations, which is where you slide. You don't change the orientation, you just slide it in one direction. Okay, hopefully you can identify a transformation, identify an isometry, which is where the pre-image and the image are congruent. Hopefully you can identify a translation where it's a slide, and use a translation rule to translate a figure in the coordinate plane.